So in this video, we're going to take a look at horizontal shifts, which was reviewed in section 2.4 of your textbook. So let's start off with a function like f of x is equal to x cubed. And what I would suggest doing, again, this is an example of a parent function. The only thing that's happening is that the variable is changing. There's no additional multiplication, addition, subtraction, division. It's just I have my variable and I'm cubing it. This is the most basic kind of function that you would have in this instance. There is no extra bells and whistles per se. I think I've beaten the horse pretty dead at this point. So what I would suggest doing, go ahead and sketch or pull out a sheet of graph paper. And let's also generate a table of x and y values. Again, in this instance, I would suggest working with the integer values from -2 to +2. Again, it's because they're pretty easy to calculate. You might be able to do them quickly in your head. And also because we are able to look at the center of the function. Okay, so if we do -2 cubed, again, we would do f of -2, and using our function notation, that would mean that we would take -2 and cube it. That would be -8. This becomes -1, 0, +1, and +8. And I'm going to go ahead and plot these points in orange. So if we do that, here's -2, -8, -1, 1, 0, 0, 1, 1, there we go. Just making sure that I was doing that correctly. And if we connect these points somewhat successfully, we see that it looks like a snake that's slithering up or down. So what I want to talk to you all about specifically is going to be, well, what if I take that same function and this time I do x, let's do +5 cubed. There's been a transformation that's occurred here. Okay, and what I want you to note here is there is a general structure. Okay, so the general structure would read something like y is equal to x minus h cubed. Okay, notice that in the basic structure, there's a subtraction that's already embedded in there. Okay, essentially what you want to think of is that this subtraction is causing the x value to reset before you actually cube it. And what you also want to note is that what's happening in here is kind of lying to you. Okay, so if you were looking at that x minus h, you're thinking, okay, well, this is an example of a horizontal shift, as I had mentioned earlier in the video. So maybe I'm moving to the left h units because I'm seeing that minus sign. And I think moving to the left is similar to a negative. Moving to the right would be similar to a positive. This is an example of a house of lies. Okay. When you are doing a horizontal shift, you are actually doing the opposite of what you are seeing. Okay. So in this situation then, this is a horizontal shift. In other words, I'm going to be either going left or right. So keep in mind the idea of house of lies. If I'm seeing a +5 in there, that means that I want to move to the left 5 units. The reason being is I could rewrite this so that it fits the structure a little bit better. So instead of a +5, I can rewrite this as a -5 cubed. And here is where it's clear that I want to move to the left 5 units. Okay, this minus sign that you're seeing here is the same minus sign that you're seeing in the general structure. Okay, I hope that I've explained that okay. If I haven't, I would appreciate some feedback, and then I can always go back in and correct or maybe smooth out the rougher edges of the explanation. Okay, so we're going to go ahead and graph this now. We're going to graph our x plus 5 cubed. And again, I'm going to work with that basic table, the same one that I generated above. -2, -1, 0, +1, and +2. And if I'm moving to the left 5, that would mean what axis am I moving along? And hopefully you're saying, well, you're moving along the x-axis because that's the arrows are indicating that it's both going off to the left and to the right. Okay. If I'm moving to the left 5, I'm going to subtract 5 from all of my x values because that's the axis that is being impacted. So if we were to extend the table and polish out these points, we would have -7 because -2 minus 5. And notice that the -8 is left unchanged because I'm not moving up or down, so my y values are going to stay where they are. This is going to be -6, -1, -5, 0, -4, 1, and -3, 8. Okay, so 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. So here is -7, -8. Here's -6 and -1. -5, 0, 4, +1, and then 3, -8. So let's connect those. So compare your work here. So maybe in this yellow-orange box, that's your original parent function, to the one that you see in the green box. Does it look like I've moved to the left 5 units? Okay, so kind of think of it this way as well. If I were to move this back 5 units, do you see that I'm getting back to my original function? Okay. So that's another way that you can kind of check to see if you moved it to the left 5 units. Right. I hope that this has been helpful.